All right, so like I said, there was a good chance that I'm going to be absent on Monday. It is still up in the air. Right now, my girlfriend woke up a little sick this morning. Something's going around the bug. Hopefully, if she feels better by tonight, we will still end up going. If not, I will be here on Monday. You won't have to worry about me missing class. Nonetheless, you will either have me or the video. But nonetheless, I wanted to change the order because I'm not going to be here on Monday. What we were going to do on Monday, I want to start today because I feel it's harder than what we were going to do today. Okay? So I'd rather be here for that to answer any questions and whatnot. So this is day 2 stuff for unit 6. Here we go. Riemann sums and definite integrals. So we are trying to get from here to definite integrals. Definite integrals is a new thing for you this semester for sure. Now it says, to estimate the area bounded of a graph of f of x. So let's say that this is f of x. And we want it to be between the vertical lines x is equal to a and x is equal to b. And we're saying our goal ultimately is to get all of this area between the graph and the x-axis. That's our ultimate goal. Now, partition, we're going to break up into a bunch of rectangles, otherwise these subintervals, and we're looking for the areas of said subintervals. Yesterday we drew rectangles with the height and the left endpoint. So when we did left Riemann sums, we were looking at the base's width, and you even did this in group today. And this y values would give you the height, so base times height. When we did right Riemann sums, the same thing, only we were looking at what was the right tip's height and the base multiplied together to give you the area. We also looked at the midpoint. Okay, so the midpoint is this x and this x value has an average that is right here in the middle. If I throw that into the function, it will spit out a y value that is here that gives you the height of this rectangle. Okay, so we had to find the average of the x's, plug it into the calculator to get that value, and multiply it by the base, the entire base, not just half the base, so that we could get the area here, the area here, the area here. And last but not least, we did it with the trapezoidal. Okay, and the trapezoid was averaging the y values, whatever they were. So this y value added with this y value divided by 2, and multiply that with this base's length, and you would get the trapezoidal sum. Now, what we're going to do here is we're going to do an arbitrary x value called c sub k. This is a little different. Don't let it throw you off. In other words, we're saying that this could exist anywhere as far as on the interval. It doesn't have to be the left, it doesn't have to be the right or the midpoint or even trapezoidal. It could be anywhere on the top of that rectangle. So let me draw a rectangle real quick. Let's say that I wanted to have a rectangle that looked like this, and then another rectangle that looked like this, and then another rectangle that looked like this, and last but not least another rectangle that looked like that. This almost feels like I did it not at left, right, not even at midpoint. It almost feels like I did it like 30% of the way or 25% of the way. Do you agree? Okay, so this we're going to call this like c sub k. So that the y value at this specific arbitrary x would be f of c sub k. You with me? This right here, what I just drew, is the height of the first rectangle. The base is going to be whatever this delta x value is, so that I have base times height. Go with me? Okay. Ultimately, how many rectangles do I need so that I have the perfect area with no over approximation? approximation or under approximation? I need an infinite number of rectangles. You can't count them. I need an infinite number of them. So there's a bunch of these rectangles that are going to be added together, and that's where we come in with this notation right here. Okay? So the area of the rectangle becomes the base times height, which in this case is delta x times the height. Okay? And the sum of all of them would be like if I said the sum from the first one all the way to the last one. And we can say this is like the limit as n approaches infinity, where ultimately we're saying that this n is like going from 1 to n. So add them all up. Add all the infinite number of rectangles, where you're doing the base times the height. You with me? And this sum is called the integral. Any questions so far? Okay. This is the exact, guys. This is the exact one. Okay? And the way we're now going to notate all of this is the following. Notice my highlights, okay? Here we go. So I'm looking at this notation right here, and I'm going to talk you through it. This is the height, which is f of x. You with me? F of x is any given height. So if I have a graph, it looks like this, f of x is going to change. Look, I'm going to use the blue highlight the way I did over here. This f of x is like 10. This f of x is like 15. You see what I'm saying? It's changing throughout. That's why the variable is x right here, because it's going to change throughout all the span from A to B. This is saying starting from left all the way to, let's say, B, we're trying to find the area between f of x and the x-axis. And that whole entire answer is all the area in between. Any questions from what you see?
What does that dx
The delta, okay, awesome question. Yes, you'll get bonus points for that here in just a bit. The dx is representing the width of each rectangle. You with me? What is the width approaching? 0. Could I put a 0 there? No, because everything would be 0. But it's called an infinitesimal, okay? So a small little, it's like a differential. It's the width wanting to be 0, but can't be 0 because it would all 0 out. You with me? Back in the day, when things were easier, we took the derivative and it looked like this. Do all of these things, whoa, that's weird. Do all of these things mean the same thing?
Yes.
Yeah. So why did we have this from the German Leibniz, Gottfried Leibniz? Why did we have dx's there? What was it representing? Nice. In respect to x. So if I said find the derivative in respect to x of 6x squared, you would say what? 12x. But if I said find the derivative in respect to x of 6y squared, you have to do implicit differentiation. You can't just say 12y. You with me? So it's like it has to be in the same language per se. In terms of has to be in the same of in respect to. So here we go. That's an awesome question that he asked. If this is in dx and this is in x, you can't integrate. it has to be in the same letter, in the same notation. You with me? Okay? All right. Any questions? Yes?
What does that K mean? K equals 1?
K is just saying from the very first rectangle, look, K is 1 right there. K is 2 is right there. Pretend that they're kissing, all right? Pretend that they're right next to each other. There's no void. There's no space. Okay? How many of those am I going to line up? An infinite number of them, so that I have no over or under. Questions? Okay, so that's what's going on. That's the notation. In your notes for me, please. This f of x is called the integrand. It's the function, guys. This is the function that you will see. It represents, like, let me do this in green. The integrand right here is representing the function right here. Pretty much everything. Go with me? Okay? And then from A to B, everything else is color coordinated, so on and so forth. Ready? Here we go. So what we're going to do now is we're going to look at properties of these integrals. And these are called definite integrals because they have these bounds. All of these bounds, they're telling you from a point to a different point. From one x value to this specific x value. They're called definite integrals. If they didn't have those bounds, it would be indefinite, and we will talk about that next time. Okay? Any questions? Here we go. The derivative of f of x is f prime. What's the derivative of f prime? F double prime, otherwise acceleration, right? What's the derivative after? F triple prime. F triple prime is that jerk. Okay, if you've seen Inception, it's that, I forget what they called it in the kick. It's like when you feel like you're about to fall and you're out of control, right? When the chair is leaning over and you're kind of like leaning back and all of a sudden you lose balance, that kick is the jerk. Okay, it's the rate of change of acceleration. What we are doing this semester is we are coming out of the dream per se. We are integrating. We are going backwards, anti-deriving. Okay? And the furthest notation-wise that you can take the antiderivative goes to capital F of x, and it stops. Okay? I know that you've been seeing this as your reality, but in essence, since you can still integrate this function, it stops at F of x. Okay? Here we go. So what's the integral of f of x? Well, it would be capital F of x. Right? And you're seeing this go from A to A. Can someone tell me what will the area equal if I go from A to A? 0. Okay? This is going to be 0. If you didn't understand this, f of x, we'll get to it here in just a bit, but know that this is 0. This right here, I'm going to ask you, I'm going to call on you here in just a bit. This is read the following. Here we go. The integral from B to A, which is left to right, of this function in respect to x. Okay, you with me? Here we go. When I go backwards from f of x, capital F of x is created. But what was the most important word that we said last class that stood out the most of what that meant when I was taking the antiderivative? What was the most important word we said? It was one word and it started with a D. Displacement. Displacement. What does displacement mean?
Distance from your original point.
3 words.
Total distance traveled.
Nope. Displacement is change in position. Let's write that out because some of us forgot. Displacement is change in position. Otherwise, the final position minus the initial position. Okay, so here we go. When I integrate from f of x and I go back over here to capital F of x, this can be seen as that capital F of x. This is that displacement that just occurred, but it's all about this. Okay, here we go. So the way I'm going to write that is the final position minus the initial position. This goes right here. Why did I not put f of b minus f of a? Doesn't b come after a?
Does it matter?
So it does matter. This right here, because you read it low to high or left to right, this one would be the final and this one will be the initial. You with me? So it would be f of a minus f of b in this particular one. Okay? Oops. Alright, so let's go back. So the answer there is f of a minus f of b. Here we go. New one. What does a k represent? Constant. What did I do at the very beginning that was so important with constants? The very beginning of the year. I took them out. I put them over here near the door. Remember? I'd even walk over and I'd even physically create this visualization of you removing the constant, because you cannot integrate that. You don't have to. You can pull it out and you're only integrating the things that have variables in them. Okay, here we go. What is the integral of lowercase f of x? Uppercase f of x. But it's a displacement. There's 2 of them, right? This is going to equal, let me write it over here so you see it cleaner and better. This will equal, and this is how I want you to write it, f of something minus f of something. Can someone tell me what goes in the first parentheses? B. Because it's the final position minus the initial position. What is wrong with my answer right now? I forgot the K. What is still wrong with my answer right now? Parentheses. Nice. And I'm trying to help you find all these mistakes right off the bat. If you wanted to distribute the K and say K f of B minus K f of A, that's still correct. Okay? All right, here we go. C lies between A and B. So how can I write this? If C lies between A and B, how else could you write what I just boxed? Go ahead.
So, like the integral of f of x from a to c with respect to x,
Woo.
plus the integral from c to b of g of x with respect to x.
Or still f of x. Those 2 boxes are equal. You see what I just did? I integrated, and now look, some people see it fast, some people don't. That's f of x. If this is f of x, and I have it like this, and I know that from A to B is a certain area. Sorry, the computer's slower than our math. All Rovik did was he knows that this C lies in between and he broke, oh, that's not a C. He broke it up into two intervals. He said this blue area is this. And this red area is from C to B. And if I add them up together, it's the same as going from A to B.
Do you go farther than that though? Like how we did up there, where f of b minus f of a?
You can, but from what this is asking, it's just making sure that you understand that C can be in between, and you can break one big area into two smaller areas.
Okay.
Okay? Question? Please ask me questions if you got them, okay? Alright. So now let's go to this right here. Start trial and erroring. Remember, if you even guess and you're wrong, you're getting bonus points for your team. How could I rewrite that? First of all, let's read this. Alec, read this for me, please.
Integral from a to b. What do you say? F of x plus g of x with respect to x.
Perfect. That's exactly how you say it. The integral from a to b of f of x plus g of x in respect to x. Or you could have said it the way Robic would have. The integral of f of x plus g of x from a to b in respect to x. You with me? Okay. What do you think I want you to write? Go ahead.
Maybe f of, or capital f of b.
Okay, so here we go. We're not necessarily integrating yet. Let's not integrate yet. I wanted to see if you were going to go there. I just want to rewrite it. Kind of like what I did with this one over here. You can separate them, yeah. Go ahead, Omar.
The integral from a to b of f of x in respect to x
Perfect.
plus the integral from a to b of g of x in respect to x.
There you go. Y'all see what just happened, guys? For bonus points, what just happened? You've done this before, a long time ago. What did I just do? It wasn't constant multiple rule.
No. It's decomposition of just whatever for you.
Not necessarily decomposition. It's not factoring. A lot of people think it feels like factoring or distributing, like a GCF. It's just applying a law. Remember? It's been a while, but look at this. I'll highlight it as I go. The integral of the sum is equal to the sum of the integrals. Remember that when we did limit laws? Remember that? So the limit of the sum is the sum of the limits. That's the same thing going on here. So yes, over here we could say from a to b, f of x in respect to x minus from a to b. Notice that this one's not ab and cb. These are both ab's. It's like you're treating them as two different problems that look like that. You with me? So the integral of the difference is equal to the difference of the integrals. Okay? If I have h of x like this, who can tell me what h prime of x? Actually, I'll tell you. Is this the answer?
No.
No. Because I should have done what? Product rule. I should have done the first times the derivative, the first times the derivative of the second plus the second times the derivative of the first. So it would have been the first times the derivative of the second plus the second times the derivative of the first. This is called product rule. These are not the same. Therefore, this would not, it wouldn't be the integral, come on, the integral of the product is the product of the integrals. We're going to have to do something called reverse product rule, which is use substitution, and it's finally awesome, awesome, good stuff. Okay? Questions so far? Alright, here we go. So let's see what you've learned. I know it's been a minute since we've done geometry. Hopefully it comes back. We're going to sketch and evaluate by using geometry. Okay? Who thinks they know what the answer is to that first? It's 20. Okay. And only because she was here during, no worries. She was here during Eagle time and I was helping someone on that. No worries. So here's how you do it. What's the function?
F of x equals 4.
4, yeah. F of x equals 4. I like the way Braden said that. You could say it like this, or you could say it like this. If I draw it, because of this word, I just drew it. You with me? Y equals 4. So if y is equal to 1, 2, 3, 4, but I'm looking between 1 and 6, left to right, I'm looking to find this area right here. What's the shape? Rectangle. What's the area? Base times height. What's the base? 5. What's the height? 4. What's the area? 20. So it's 20. Nice question. Nice question. She's saying, should I put units squared? Should I put units? Right? Right now, 4 doesn't have units. If 4 was like meters per second, what would the answer be? 20 meters. You with me? If 4 was people per hour, what would the answer be? People. You with me? So for this one, just for now, we're just going to leave it as a number. It didn't say area bounded. It's just an integral. If there's area bounded, then we'll put units squared. You didn't see the 2 words, and write it down in your notes if you need to. You did not see the 2 words area bounded. Some questions will ask, what is the area bounded? Then use units squared. Because then you're talking about geometry interpretation. Okay?
Oh, so the units squared.
Yeah, this is big right now. I'm about to award points. If it said area bounded, you put units squared. If it doesn't say anything like this, you put 20. If 4 was representing people per hour, you put people, right? Because the first one that I said with area is strictly area like geometry. The last one that I said, what were the 3 words that I'm looking for you to say? No. The last one where it was people per hour would become people. What 3 words did we learn last class that I'm looking for you to say? Here it goes. Accumulation of change. It's the accumulation of change. It's big, conceptual. All right, here we go. What's my next function that I'm going to draw? X plus 2. Here we go. 2. What's the slope? 1. And the bounds? 1 to 3. So then my area can be seen as a triangle in a rectangle or a trapezoid. I hope you look at it like a trapezoid. Because if you look at it as a trapezoid, you just did this in groups. How do you find the area of this? Well, you need to average your y values. Can someone tell me what the height of this first one right here at x is equal to 1 will end up being? 3. Because if you put it into the original function, 1 plus 2 is 3. What will the height be at x is equal to 3? 5. What's the average of those y's? 4. Multiplied by what?
2.
The height, otherwise the delta x of 2. Oops, is it? 8. You with me? All right. Who wants to guess the shape of C? Not you, Jordy. Who wants to guess?
It's a circle.
It's a circle. How did you see it so fast?
I just knew that.
How?
Because that's the
Stole my thunder, bro. That's okay. Alec, nice job. How do you know this is a circle?
equation for a circle is x squared plus y squared equals the radius. If you solve
Radius
for-
squared, right?
Yeah, radius squared. You solve for y.
So look, guys. This is why I like the way Braden was saying it earlier. He was saying f of x equals this, which is the same as y is equal to this. And like Alec just said, he's exactly right. You can solve for this by doing what to both sides?
Squaring.
Squaring. And then?
Square rooting.
No.
Adding
Adding
that.
the x squared over to the left side. Technically, this is the equation of a circle. Why do I have h and k?
The right.
The coordinates. It could be like, if it was x minus 3, then it's going to be at 3. If it was y plus 5, it's going to be at negative 5. Because everything in parentheses, we interpret the opposite. Okay? So this is a circle. Where's the center? 0, 0. What's the radius? 2. 2, right? Why did I only graph the top one? I didn't graph the entire circle. Why?
It has to be a function.
No? Whoa, touche. But you, okay, listen. You could take the area between curves. A circle is a curve because it doesn't have to pass the vertical line test. This is a function. He's right. But this one only has the positive one. Why?
You can't take the square root of a negative.
Okay, so you can take this, you're right, you can't take the square root of a negative, but it's not that. Watch, careful with the words.
Because if there's the only, that's the real part of the circle, like not imaginary.
That's where he was going with. Keep going, Arjun.
Wait, no, because I was gonna say the range between -2 and 2.
This is why. What Alex said, this is actually a half a circle. You with me? This is the bottom half of the circle. Because the complete circle in this form would look like this. You with me? The positive is the one that's above the x-axis. The negative is the one that's below the x-axis. Because this one only had the positive right here, I'm talking about the sign in front of the square root right here. That's why we're above the x-axis. What's the equation of a circle? Careful. What's the equation of a circle? Sorry, I said it wrong. Thank you. What is the equation of the area of a circle? R squared. What's R? 2. What's the area right here? 2 pi. Because we had to divide by what? 2, because it's a semicircle. Here we go. This is f of x, right here. And this is why you should learn and see and understand fully, why we say that the area is displacement. This area is blank. What goes in the blank? Negative. This area is what? Positive. And this area is what? Negative. So if I looked at this and I wanted to find all of these areas, here we go. Watch my highlights, please. And I don't mean in my hair because I'm bald. Right here, can those be a base or a height that I just highlighted? Can those signs be a base or a height?
Yes.
Yes. Can this hypotenuse be a base?
No.
No. Because bases and heights must always meet at blank degrees. 90 degrees. So I'm going to highlight this again. Those are base and height. this is a base and or a height, right? In this case, the one going up is obviously a height, and this is a base and a height. Here we go. We have, we're almost done. We have 3 rectangles that have 1/2 times base times height. Can someone give me the numbers for the first one? 1/2 times, go ahead, say it out loud. 3 and 2. What about the second one? 3 and 3. You with me? What about the third one? 2 and 1. Now, yeah, so this is the way I would do it. Some people, instead of a 2, would put a -2. Okay, you don't have to do that. I look at it just like regular geometry, and I see that this first one's area would be 3, but because it's below the x-axis, I would say that this first area is -3. What would the area be for the second one? 9/2 or 4.5, same thing, I like fractions. What's the area of the last one? Not 1, a -1, because it's below the x-axis. And this is where the negatives, he's getting points for bringing that to my attention, where the negative errors come when you make this semester, okay? Are we good? Alright, so what did I say this is? -1. Can someone tell me this -4, which is -8/2, what will be my answer? 1/2. 1/2 is displacement. That means if I'm here, all I did was move 1/2 step forward.
So is that a velocity graph?
Okay, this is where we're going. What I just said was wrong. This was the result of moving forward, right? Like if I'm standing right here, so some people don't know and they're absent, this right here is 1/2 step forward than where I'm at. This is where I will end up. Okay? I don't know why I'm like that. But anyway, so, but what actually happened in this graph is I wonder if it'll let me. What happened is we had a negative velocity at first. Do you agree? If this is a velocity function, it was negative because it was below what? The x-axis. So for this first interval, right? Let me see if it'll let me. Oh, that's kind of close. So I moved back 3. I moved up 4.5. And then I moved back 1. So that I resulted in a displacement of 1/2. Cool? No one liked my animation. No one smiled. I was going to give you bonus points. But anyway, so let's go ahead and move on. If from 0 to 3 is 4, with me? And from 3 to 7 is -1, what's the answer to A? 3. What's the answer to B? Nice. Because if you use constant multiple rule, you already know that this 3 to 7 is -1. What's -1 times 2? -2. And what would the answer be for C? 0. Are there any questions you have?
So when they give us like a graph, do we always assume it's a velocity graph? Or let me ask this first. If you have a velocity graph,
When they give you a graph, you always, he's like a day, almost 2 days ahead. When they give you a graph, the assumption default is that they give you the velocity graph. So they're not giving you f of x so that when you integrate it you become capital F of x. The default is they're giving you f prime so that it's the change between these two positions of the final minus the initial. This is called the fundamental theorem of calculus. He's 2 days or a day ahead, but that's the default. Now listen, check this out. Y equals mx plus b. You know that. Okay? B is my initial. Y is my final. Do you agree? Come on, baby. So mx is the accumulated change. So initial is f of A, final is f of B, and if I subtract this over, it's like saying f of B minus f of A is equal to mx. You ready? This is the slope. This is the slope. This is with x. This is with x. This is the same as this. And it's what you've been doing since y equals mx plus b. How many of you understood that? Okay, so bonus points for all 3 teams. Cool. Day ahead, 2 days ahead, it don't matter.